That's not what I want. Okay, here we go. The last lesson. Are you ready?
Yes.
Woo! Okay. I'm really excited.
The only thing I just read about
Well, suck it up.
she's like, I can't.
Okay, so I don't know if you really need to write this down because you know it all. Okay? You know that the derivative of position is velocity. And you know that the derivative of velocity, which is the second derivative of position, is acceleration. Yes? So, this is what you need to write down. How is position related to velocity? It's antiderivative. If we have velocity, we can take its antiderivative to get to position. And if we have acceleration, we can take its antiderivative to get to velocity. Half of our lesson today. Trying to work backwards. Now, what we also need, though, if we have velocity and we're trying to get to position, if we have acceleration and we're trying to get to velocity, we need to know an initial condition in order to be able to get the entire equation. Otherwise, we have that pesky plus c. Okay? So in these problems, you're going to get an equation with a condition to where you'll be asked to find that constant. So go ahead and write down that we have a velocity of cosine of pi t, and our position is 4 at t equals 0. All right, we know that our position is the antiderivative of velocity. And Mr. Grubel and I plan out calculus in a way that we save motion for the end, so we get to review everything. We've reviewed some derivatives, we've reviewed minimums and maximums, and now we're about to review some antiderivatives. Okay, so what is the antiderivative of cosine? I heard sine and I heard negative sine. Is it positive or negative? Still I'm not sure. It's positive because the derivative of sine is a positive cosine. However, we have a coefficient in front of t, so we do need to make up for the chain rule. And we need our plus c. Okay. Well, we have an initial condition. The position is 4 when time is 0. So, our position is 4 when time is 0. So, what's C? What's the sign of 0? 0, so C is 4. We'll get there. So our position equation is 1 over pi sine of pi t plus c.
That would be plus 4.
Oh, thank you. I was looking up here to make sure I wrote it down correctly, and then I wrote the c instead of the 4. There we go. We got it down.
That was our celebratory dance.
I liked it. I appreciated it. Okay. Now, what if I give you acceleration and I say, hey, find me position? How many times are we going to have to go through that process? Twice. And we would need an initial condition about, or some sort of condition about velocity as well as position in order to get all the way there. So make sure you write down that our acceleration function is this, and then our conditions for both velocity and position. So, if we have acceleration, then the first thing we need to get to is velocity. So we know velocity is the antiderivative of acceleration, okay, which means our velocity equation would be t cubed plus t squared plus c. That worked out pretty nice for us, didn't it? Okay. So now we can put in here that our velocity is 2 when t is 3. What's c? What? Do you agree with Turner? Yeah, okay. So now, if we want position, we need to take the antiderivative of t cubed plus t squared minus 34. Oh, Mrs. Holman forgot her dt. I'm very sorry about that. So our position equation is going to be 1/4 t to the 4th plus 1/3 t cubed minus 34t plus c. Ugh. It's not as pretty, is it? You're probably going to need your calculator for this. We need to figure out what that c value is. But we know that our position is 8 when t is 3. So I'll give you a moment. Sorry if I hurt you.
No, you're.
I try not to fist bump with this hand. C is not a pretty number. What is it?
It's 80 and 3/4, 723/4.
Okay, so 323/4 or 80.75.
That's what I got.
Okay, so either a decimal, that's a nice one, or a fraction. Just avoid the mixed number. Okay. If this were like a repeating decimal, then I would rather you make it that fraction, like 23/3. Okay, don't approximate that as a decimal. So our position is 1/4 t to the 4th plus 1/3 t cubed minus 34t plus 80.75 or 324/4. You decide. Okay, so we are going to finish out talking about the difference between displacement and distance. displacement and distance. Okay? And then we all can figure out what distance is, right? Okay? How far has this particle traveled over an amount of time? But what would displacement refer to?
How far you are away from the starting point.
Okay? How far do you end up away from the starting point? Okay? That's very good. So, where are we ending at a particular time? Okay. If we have negative displacement, what is that going to mean? Well, if we're talking about side-to-side motion. Okay. Negative displacement means the particle has ended on the left. Positive means we're ending up on the right. And 0 means we're at its original position. Okay? And displacement, like Lauren pointed out, is always relative to where we begin. Okay? So if we have negative displacement, we're to the left of where we began. If we have positive displacement, we're to the right of where we began. And if we have 0 for displacement, that means we ended where we began. Does anybody have an idea of how we would find that? Ooh, final minus initial. Okay.
What?
Final position minus initial position. Which could also be described as the integral of the velocity from A to B. Right? Okay? So when you are asked to find displacement, you're going to take a definite integral of the velocity. Okay? Because the first fundamental theorem of calculus says that the integral of velocity from A to B is going to be the antiderivative of B minus the antiderivative of A, which is what Dylan just described. Okay. Now, don't write this down, but I want you to think about this. If this was a velocity graph, okay, and I'm asking you for displacement, if I take the integral of velocity from A to D, what would it equal? Four? 5 plus negative 4
Yeah.
plus 3.
Yep.
So we would have a displacement of 4. So we would end up 4 to the right of where we began. If I cut it off here from A to C, then our particle is going to end up only 1 to the right of where we began. Okay? What's nice if I don't give you a graph and I just give you an equation, all we have to do is take the interval. So go ahead and write displacement at least so you know that's what you're calculating, and write down this information right here. So if we want displacement, we're going to take the integral from 0 to 3 of t squared minus 2t dt. get? So we would have 1/3 times 27 minus. Huh? You did math 9? You got 0? Okay. All right, so Turner, what does it mean?
So if displacement 0, we're asking the origin to move like left or right.
Okay, so instead of origin, we don't know if this guy started at the origin or not, but whatever happened between 0 and 3, we came back to the original position. Okay, so we're back to the position that we had at time 0. Okay. Now, did this particle just not move at all? Okay. We would know that it moved because we have, like if we plug in numbers between 0 and 3, aside from 0, we're going to get values for velocity. So we know that it's moving, okay? So while it has a displacement of 0, surely it traveled some distance, right? Okay, so when we talk about distance, okay, same kind of thing, we can have a particle who moves 100 meters to the left and then 100 meters to the right, and so it has a displacement of 0, but it traveled 200 meters. How are we going to calculate distance? If we took the integral of velocity to get displacement, have a discussion at your pod real quick. Brainstorm.
Well, so when you had the graph, it was like 5.3. You were just adding this, added up the graph, so you would be that like being positive. Added positive, you would have
All right, who has an idea? Aaron, I heard you talking a lot.
I don't know. So we had the graph where it was like 5, -4, and 3, and then
Okay.
we were to add up the areas and like make that -4 positive. We took the absolute value of it, then we would have got the distance.
Okay, so if we take the absolute value of our individual velocities,
Yeah.
we would have our distance. Does that sound reasonable?
Yeah.
Like what he's saying, if we come back to here and we make this a positive 4, then we could say that the distance traveled was 12. Aaron, I don't know why you were so worried about trying to tell me that, because that's exactly right. Okay, to find the total distance, we're going to integrate the absolute value of velocity. Have some confidence. Okay, so I want you to write that down too. Good job, Cody. Just one step ahead. Okay, now what's going to be important about the velocity, or what do we need to know about the velocity before we go and calculate the distance? I mean, do we really want to calculate an absolute value antiderivative? No.
The zeros of the velocity.
Okay, it's going to be important that we know the zeros of the velocity so we can determine where the velocity is negative and understand that the negative area we would find, we would need to turn to positive area. Okay, so you need to find the zeros of the velocity so you can find intervals where the velocity is negative. So that instead of taking an integral of an absolute value, you can break up into multiple integrals of positive areas. So in other words, you're going to figure out where the velocity is going to give you negative area and change it to be positive. Okay, so we're going to do one example where we find the distance, and then we're going to do one example where we find distance and displacement, and then we'll call it a day. Just for you. We'll call it a day after that. You ready? Maybe not? Jesse, you
Or
keep
just
ready?
take a picture of it, write it down later.
I can let you keep writing.
No, I'm a slow writer.
Okay.
It's all good.
Okay, you just skip a couple lines and walk up.
Yeah.
Okay. All right. So, oh, hey, look at this. Same equation, right? So if you want to rewrite it down because it's in a different part of your notes, I'll give you the time to do that. But make sure you specify that we are now finding distance. When you go to look at your notes, I want you to be able to tell whether you're finding distance or displacement so you have that to compare to. I don't want you to get them mixed up. So we need to know where the velocity is negative, which means first we need to know where it's 0. Where's the velocity 0? 2 and 0. Okay. Okay, and we really don't care what happens after 0, but between 0 and 2, what kind of velocity would we have? Negative. And between 2 and, 3, we have positive velocity. Okay, so what we are going to do to find our distance is we are going to break up the integral from 0 to 3, absolute value of velocity, dt. We are going to break this up into as many integrals as we have different chunks of velocity. So we have 2 different chunks of velocity, which means we're going to break this up into 2 integrals. One integral is going to go from 0 to 2. And one integral is going to go from 2 to 3. Now, since we have positive velocity, we're going to keep 2 to 3 the same. But from 0 to 2, since we have negative velocity, we know that this is going to give us negative area. So we're going to change the sign in front of it to ensure that it's going to become positive for us. Okay, so just to save time today, I'll let you go ahead and do Math 9 with this. Huh? I do my best. Did you get something, Turner?
8/3.
And you would want to put a label on it. So since velocity was meters per second, we know that our distance would be 8/3 meters. Okay. So the biggest thing here is that you figure out where your velocity is negative and turn those integrals to negative integrals to counteract the negative area. Okay, so this is going to require a little bit more work on your part. Okay. Okay, so our last one. I want to find the distance and displacement of this guy.
For the last one you said, I'll let you use McBride. Will we not always have our calculators for these problems?
You could have some of these on the non-calculator part of your final.
But like
Of our final.
Oh, final.
On the test, you'll have your calculator. Our test is Wednesday. Is that right? Yeah, okay. Because Monday is going to be an AP problem day. Tuesday is going to be review. Okay. Okay, well, if we're talking about distance and displacement, we like to do that with velocity, right? Okay. So we need to, yep, which is what, Eli? It was your idea.
-2 something.
Okay. Let's vote. How many of you would like to do distance first? How many of you would like to do displacement first? How many of you could care less? There we go. Okay. We'll do displacement first because I saw 3 hands compared to 1. So essentially we have 2 cosine of 3 pi over 2 minus 2 cosine of 0. Well, what's the cosine of 3 pi over 2?
0.
Okay. What's the cosine of 0? Okay. So our distance is, or displacement, excuse me, is here too. Okay. Which means we're 2 to the left of our original position. Now, in order for displacement, we do need to know where our velocity is 0. I understand that the sine of t is equal to 0 multiple times, but what we need to be concerned about is between 0 and 3 pi over 2, when is the sine equal to 0? 0 and prime. Colby, we're finding where the velocity equals 0, so we can figure out where the velocity is positive versus negative.
Oh, okay. I thought you said for displacement.
For distance. Okay, we're done with displacement. Okay. So if we make a sign chart, and really, put on that, there you go. Perfect. Okay, I really only care about from 0 to 3 pi over 2. Okay, what kind of velocity would we have between 0 and pi?
Sine of pi over half.
right? Because with -2 sine of t, okay? And we would have positive over here. So in order to calculate our distance traveled, we want the integral from 0 to 3 pi over 2 of the absolute value of our velocity. So we'll break our integral up into two integrals, one from 0 to pi and one from pi to 3 pi over 2. But since 0 to pi has negative velocity, we got to throw a negative out in front. Okay. So if you were to punch this in your calculator or do it by hand because it's really not that hard of a problem, we get 6 meters. So while the particle ends up 2 to the left of the origin, it travels 6 meters on its way there. Okay. Good luck.
Thank you.
Tell Lauren good luck. I didn't get that before she walked out. Okay. This is your last daily homework assignment before we get into reviews for the test and then reviews for the final. Okay, I'm not telling you that you're not going to have homework again. You are. But this is like the last non-AP homework that you're going to have. Okay. Thank you. I'll give you, did I give one to your sister already? Probably not, so there's one for her. Can you see her?
Yeah.